Welcome to another edition of Math That Matters. We're in lecture FM6, and we're going to talk about amortized loans, something Neal was alluding to a little bit last time. But I have a question first, Neal, because I know that you went surfing last weekend, and I would never go surfing because I know what's out there, right? I know that there are sharks out there, and I think that you may have gotten bitten on the head. Is that true? Is that what happened?
I did get attacked, but it wasn't by a shark. It was by a tailgate on the rental car.
A rental car. Well, I got to stay away from those as well.
It didn't attack me, but I attacked it by just running into it. How can you not see something at eye level?
I don't know, but all I have to say is well done.
Yeah, okay. Well, I survived this. We did see a shark, and you would have loved it. I'm taking you surfing.
Oh, man.
That's one of my life goals, is to take you surfing, because we're going to have so much fun.
I'll watch you from the sand.
Okay. We are back for amortized loans, as Pete said, and just as a refresher, to kind of remind you, an amortized loan is a special kind of loan, and it's special in that whenever you go in and make a payment, these regular payments, R1, R2, and R3, three things happen when you make that payment. First is you calculate the interest, and you pay it for the last period, right? You go ahead and clear the books. Second, whatever is left after you calculate the interest from that payment is applied to the principal, which knocks it down, and now you have a new principal going forward. Right,
which is why the second rental payment, the second amount of interest, is different than the first amount of interest, right?
Exactly, yeah. These interests are going to change. The cool thing is the payments never change, right?
Okay.
They stay the same. But the distribution of interest and principal is changing as you go through the loan.
So these green numbers are actually going to be getting bigger or smaller?
They're going to get bigger. Yeah.
Oh, because I'm actually borrowing less money the next time because I've paid off my loan.
If you think of our chair example, it's almost like you borrowed a bunch of chairs for the Christmas party, but after an hour or two, you took some chairs back.
Yeah.
You return, hey, so here's some chairs, and we're going to pay you the fee for borrowing those chairs now, but now we want you to charge us less interest next month because we're borrowing a few less chairs.
That would be fair.
Does that make sense?
That makes a lot of sense.
That's what, and you can make these payments whenever you want. But that payment is going to stay constant. And we ended our last class with this magic formula that's really important that kind of governs the whole thing. Make sure you understand these terms, especially the capital R is not interest rate. That actually is the regular payment, that magic payment that you make all the way through the loan. And we're going to do an example of this so you understand a little bit more about how they work. And I'm going to set that example up on the board now. Okay, we've got an example, and you might remember from our last class, Pete had this great idea that I'm supposed to buy Susan a new Corvette.
It seemed like a good idea.
Yeah,
what did Susan say about it?
Well, I didn't even run it by her. You told me it was a good way to love her, but I ran the numbers, and it's really not possible.
No.
But I do have another idea. I'm gonna buy her a new car. I'm gonna buy her a new old car.
Okay.
And I found this 1950s Edsel. Yeah, it's this old classic Edsel.
That's pretty cool.
It's in contrast to the Corvette that you wanted me to get her.
Yeah.
But the Edsel costs $6,375, so that's going to be the loan amount.
Fair.
Yeah. An interest rate of 9.5%, and we're going to have a 3-year loan to pay this off. Because I don't have this kind of money now, so over 3 years I'm going to make payments for it.
Okay.
Here's the question that we have for you guys. What do we need to solve for? I'm going to take a loan out for this car, and I'm going to pay the loan off over 3 years. What do we need to figure out? That's question one. Question two is, how much interest am I going to end up paying for the privilege of borrowing this money, right? I'm going to borrow $63.75. I'm going to pay them a little bit interest. How will we calculate the total interest on this loan? So why don't you pause the video. This is one of your big lecture questions, and try to solve those two questions right now. Okay, not sure what you came up with, but the first question is, what do we need to solve for? And Pete, what are your thoughts? What's not known here?
Well, it seems like I would want to know how much my monthly payment is, but it does also seem like something is missing, and I maybe even gave a little bit of an indication as to what was missing in that answer.
Yeah, you actually said something really intuitive. You said my monthly payment.
Yeah.
So it reminds me that we're not sure how often these payments are. It's flexible. It can be anything you want, right?
Sure.
You assumed it was monthly. Why, Pete?
That's just the way life works, right? Yeah. N is almost always 12 in most of the problems.
Almost always. Now, we're going to do an example later on where it's not 12, just to show you there's some flexibility. But Pete's assuming a monthly payment, and so we need to know what that monthly payment is. Once we figure that out, we can start to process this loan. And notice, by the way, the example up here on the board, I showed a payment every year. What Pete's referring to is we'll start making payments all the way throughout here, right? So we'll have 12 payments in the first year. We'll have a total of 36 payments to pay this loan off. So question 1 here is, what is R? Okay. Well, how are we going to solve that, Pete?
Well, it looks like we're going to have to figure out what all of this is, because we do know little r, we do know little n, and we do know the amount of the loan, so we can just plug all of that in. This is going to be something that's a multiplier times r, so we'll just have to divide p by this. I think
Excellent.
that's going to be okay.
All right, so we can set up using our master formula. We're going to borrow $63.75, and r is our big unknown, right? And I'm putting in parentheses here, it's a 12, just to remind me that there's going to be, n is 12, right?
Okay.
Because n is the frequency of my payments in a year.
The payment if I make monthly payments.
Right, right. If I put a 4 in here, then it's making a payment every quarter, but that's
Sure.
confusing. Okay, 1 minus 1 plus an interest rate of 0.095, sorry for my numbers there, divided by n is 12, all to what power here, Pete?
The negative 12 times 3, and make sure you put that in parentheses. Good,
Yeah.
good job.
Super important, all over 0.095 over 12, big parentheses, right? Now, we've spent a little time in class already crunching these numbers, so we're not going to waste video time on that, but you should know how to get all this boiled down to one number. Once you get this boiled down to one number, you divide this number by that, and you solve for your R. If you need help on those things, come see Pete or myself in the office, and we'll work this out. But when I did these numbers, Pete, I came out with a payment of $204.21. And by the way, that is per month, right? Notice that if we change this 12 here to a 1, for example, making one payment a year, it's going to be a much bigger payment, right?
Absolutely.
But if I make it every month, it's $204.21.
Do you
Not
think
bad.
that, is Susan worth that to you?
Well, oh, absolutely, man. Maybe I need to consider the Corvette. I can swing this. This is doable, all right? Now to question number 2. What was question 2 again?
Question 2 was, how much interest will you pay? Because you're going to pay more than this, right? But
Yeah.
how much more?
Yeah, well, I'll tell you my first thought,
Okay.
and then you tell me if I'm right or
Okay.
not. I know that interest is principal times rate times time. That's kind of the definition of interest. How do you feel about that, and how do you feel
You
about
know
that?
how I feel about I equals PRT. I don't love it like you do. It doesn't warm my heart. And it's for this reason, right?
Yeah.
That if you just use it blindly without thought, without context, sometimes it will lead you astray. But if you think just like a regular, normal person, and you say, I'm making this payment every month for 3 years, I bet you can figure out how much money it costs you. How about that?
You convinced me. It's gone. Why don't you work us through that over
Okay,
here, Pete?
sure.
I'm going to give you a little space. So question B that I'm going to set you up with is, what is the total interest?
Okay. And
To
now
pay
I
this
could
loan.
either think about this like, oh, I remember a formula with total interest. I just remember that the future value minus the amount of money that I've paid equals the total interest. Is
I
that
like
right?
that. I like that. Yeah.
So I just need to figure out how much money I paid, and well, they gave me this, so I got to subtract that
That's
off
right.
to get the interest.
It's a little
right?
tricky. It's a little tricky.
So I just kind of think about this intuitively. I know you kind of love your formulas, and that's either way is fine. But I would think about it like I'm paying $204.21 times 12.
Love it.
That's how much I've paid in a year, but I'm paying it for 3 years. That sort of looks like something familiar that we don't always love. But
I love it that 36 is there and it's here.
It's
the
right there and
total
it's
number
right
of
there.
payments, right?
And so did you calculate
I
that out?
calculated it, Pete. I had a feeling you were going here. I got $7,351.56.
So does that mean that I paid $7,351.56 in interest?
No, that's what you paid for the car.
Oh, so the car didn't cost me $63.75.
Yeah, that's it. They told me it cost $63.75.
Dang it.
I paid an extra almost $1,000.
Yeah.
I calculated that, Pete, and I got a difference of $976.56.
Yeah, so that would be the interest, right?
I like it. You know, this is ringing a bell, Pete. This right here looks like the sum of the R's,
Yep.
right? The total of all our R's, which you did by calculating R times N times T,
Yeah.
right?
Yeah, so actually, I mean, to get the car up front 3 years before I finally pay it off, at a rental cost, sort of, which it's not a rental car, but it's a rental cost for renting that money,
Right.
of just under $1,000. I'm not sure if I like that or not. Do you like that?
Well,
is that a good enough deal?
I don't have a choice because I don't have $6,375. So if I can't pay for it all right now, I have to pay them a fee for the privilege of borrowing money.
Yeah.
But at least I didn't pay interest on this amount for all 3 years because I got an amortized loan, which
Sure.
worked to my advantage, right?
Sure.
In fact, if we did I equals PRT, we would get a number bigger than that
We sure would.
because we'd be assuming that I'm paying interest for all 4 years.
That'd be
all 3
bad.
years. So.
Yeah.
Okay, so that's a quick example of how we find total interest in a loan. Every single time we ask you to find total interest, this is the only way to do it in a loan, right? There's no other way. Calculate the total paid back and then subtract from that the principal amount that you borrowed. And as Pete said, that is our most intuitive definition of interest. The difference between what you paid and what you borrowed is interest. That's the fee.
Simple.
Okay,
Simple
let's jump
math.
into one more example on the amortized loan. Okay, before we jump into this next example, just a visual of the loan that we just did. There were 36 payments over the course of those 3 years, although the payment never changed. It stayed constant at $204.21, but what changed is every payment, there was a different distribution of how much went to interest and how much went to principal. And as an illustration of that, in month 1, this payment right here, I did a quick calculation, and of the $204, $50 was paid as a fee, right, to borrow the money, which left about $150 to go towards knocking the principal down. But Pete, contrast that with what happened in the very last month.
Yeah, so in the last month, you can see your balance is pretty low, right?
Yeah.
You almost have it paid off. So the rental fee on that little bit left of balance is only $1.60, and that means $202.61 of your payment goes toward reducing the balance ultimately to zero so that you can pay off the loan.
And that's the beauty of the amortized loan, is that you aren't paying interest in month 36 on the whole $63.75 because you're only borrowing a small amount. You're down to borrowing about 1 chair at the end, and so you shouldn't pay much interest. Okay, let's jump into the next example. I think you're going to like this one. In fact, I'm just going to share it with you right now, and I'll go up. This is a secret. Pete doesn't really know about this, but Amy, Pete's wife, wanted to get something special for Pete for, I don't know if it was your birthday or something.
Yeah, well.
Whatever I'm making up. Just because he's special, I guess.
She loves me.
And so we kind of talked about it together. We thought, what would be a fitting gift for Pete? And she decided an earring. Yeah, a diamond earring.
I mean, back in the day when I was in high school, some of my friends, that was cool. That was like today's tattoo. Some of my friends got earrings. I was tempted, and I guess I never took
So
the
she
plunge.
knew you were tempted, and you'll be happy what she picked out. She picked out a nice big pendant earring. It's about that big, diamond.
It's gonna look good.
Yeah, it's got some good swag to it. It'll kind of swing in the air while you're teaching.
Well, I'm just gonna tell you, I'm afraid of sharks and I'm afraid of needles. So this is gonna go well.
Well, we're gonna have to put you under while we put this thing on you because it's kind of big. So
Yeah.
let's set up this example here. So here we go. The example is a $2,800 earring. It's a nice earring, but Pete's worth it. It almost costs as much as my wife's car.
She loves me.
We got a 9% interest, but Amy doesn't have $2,800 cash, so she's going to pay it off over 4 months. This is a real short loan. It's a 4-month loan instead of a 36-month loan.
So would that mean, that N is 4?
Well, we're going to talk about it in a second.
Okay.
Yeah, we'll talk about it. But first, Pete, you had an observation about this little chart up here.
Yeah, I've never seen someone teach this in this way with this diagram, and I actually really like it. I think it's very informative. There's arrows, sometimes down and sometimes up. Can you explain why you did that, and maybe even why you made these arrows shorter than that
Good.
arrow?
Excellent. Well, why don't you tell me, because I know where you're going.
Yeah, so the down arrow means you're getting that, right? They're
Taking
giving
money.
you some money.
That's right.
And then the shorter up arrows means you're going the opposite direction with money.
I kind of
right?
think like down is bad. It's like I'm taking money from
Okay.
them. Up is good because I'm paying them money back.
Okay, paying it off,
Yeah.
but in smaller chunks.
That's right. Excellent. And you'll notice in this one, there are 4 payments because we're going to pay monthly. And you brought up a really good question. What is N going to be in this loan?
I'm not quite sure.
Well, the definition of N, we erased it, was the number of payments in a year.
In a year, and I'm making monthly payments.
I'm making monthly payments.
So would it be 12
It is
still?
12. It is still
Okay.
12 because you're making monthly payments.
Gotcha.
Doesn't matter. What's tricky in this is that the time is going to be 4/12 of a year, or the time
so
is
T
1/3
isn't
of a
4,
year. T is not 4.
Because that would be 4 years.
That's right. because
So
4
4
months
months
is equal to 1/3 of a year.
So that's T. T is 1/3.
Exactly. Put it
Gotcha.
in there. Okay, and what we're going to do on this one is we're going to go ahead and take care of the payment. And I already did that on the side. And I did a quick calculation by putting all of these terms in there. And I came up with a monthly payment of $713.175. Now, Pete, what do you do about this? That's a half a penny.
I mean, you can leave it there and do any other calculations. And,
Yeah.
The thing is, if you do something with this number and you round it off and you take that away, then your final answer gets as much further away from the truth as your multiplier.
We may not have perfection in the end. I'm going to chop it off because I can't pay a half a penny. I don't know how to pay a half a penny. So we're going to chop it off and keep that thought in mind that this might get a little bit wonky at the end. All right. To break this down, Pete, we are going to do what's called an amortization schedule.
Okay.
And this is a new thing for you, and it really probably is the most important thing you can grasp about an amortized loan is understand the amortization schedule. So I'm going to take a quick second and draw it up on the board, and then you can rejoin us. Okay, so here's a picture of our amortization schedule. And take a good look at this because you're going to be making a few of these in your homework over the next several class sessions, and they're really, really important. They give you great insight into how an amortized loan works. You'll notice a series of 6 columns, and we're going to fill them out as we go. And each row represents one particular period of the loan. So this loan has 4 periods, right? Because we're making 4 payments. So period 1, 2, 3, 4. Now, Pete, in our previous example of the car loan, how many rows would I have for the amortization schedule?
That was 36, wasn't it?
That's right. So this would go down to 36.
12 payments a year.
So every time you have a payment, you have to have a row in your amortization schedule. We're going to do a house example in a future lecture, and those have a lot of rows because it's 30 years long every month. But this is a 4-month loan, and we want you to see a loan go to completion. Okay, each period, we want to take a snapshot of what's going on in the loan. So with period number 1, what is the starting balance on the loan at the beginning of period 1? How would you fill that in, Pete?
That's what I borrowed. So that's $2,800.
Yeah, so
that's
you walk
easy.
out of the bank and you have $2,800 that you owe on the loan. Now, we're going to make a payment in period 1. What is that payment, Pete?
Didn't we calculate that already?
We did.
Yeah.
I erased it, which is my bad, but it came out to be $713
That's right.
and 17. And by the way,
Yeah,
there was a
there
half
was
penny there at the end. So that's $713. I'm going to pay that much. Okay, what's next, Pete?
Okay, so we've got a rental fee on this that we have to calculate, and then the rest of this payment would go toward reducing the balance.
Right.
So if you want to think about this rental fee, this is a 9% annual interest rate. That is a yearly interest rate. And the reason you see R over N in lots of places is we have to take that 9% and divide it by 12 to see what percent we pay every month. If we just want to take the balance times R over N, that actually will be our interest because we're taking that percent or that piece of the $2,800.
Now, you know me. I'm going to ask you, is it okay if I use I equals PRT here, sort of? Is that what you're doing?
It actually kind of is, right?
Okay.
Yeah, but so what would P be then?
P would be how much money I'm borrowing for that period.
So 2,800
Good.
times R.
Well, this is where I like what you just said. R would be 9%, but if it's the interest for one period,
That would be 1 month out of 12.
9 over 12.
So, or you could say T is 1/12 and then R is 9%.
Yeah. So why don't you
right?
calculate the way
So-
that makes
so-
most sense to you over there?
Yeah, to me,
And we'll
the-
call this I1.
Yeah, so interest 1 to me would just be how much money I presently owe
P.
times the percent that I pay that month, which is 9%, cut into 12 pieces.
Good.
And I
Love
think
it.
you calced that out for me, didn't you?
Yeah.
Neal?
Now, there is a T, isn't there? There is technically a T in this formula.
Yeah, it's in this one too. It's 1/12, right?
Good. Well, I was thinking, could we also think of that T as being the number 1
Sure.
for one period?
Yeah.
Does that make sense?
Yeah.
So, because you're given the interest rate per period times one period.
Okay, sure.
Does that work for you?
Yeah, isn't that neat how in math there's just lots of different ways to look
Yeah,
at things
it's
that,
cool.
that work.
I
But not
just-
every way works.
Yeah, I didn't want them to think that we changed the formula to that all of a sudden.
Gotcha,
Because,
gotcha.
right, we're still there.
Yeah,
Okay. I calculated that. It's $21 exactly.
$21.
Good. Okay.
So the rental fee the first month is $21. Out of
Exactly.
my payment here, and the rest of it goes toward reducing my loan
Okay,
balance.
so show me that calculation.
Okay,
P1,
so,
what
so
would P1 be?
would simply just be the
713.17, subtracting the interest.
$21.
I did
Yeah.
that, Pete, and I
Yeah.
got $692.17. And notice how I'm filling in the columns, the rows, as Pete's going. Okay, so we have 3 steps for every row. 1, we calculate interest. 2, we calculate how much of the payment goes to principal. And step 3 is we now adjust the balance on the loan
Okay.
for the next month.
Should I say like B1
Sure. B at the end of 1.
would be, I owed $2,800,
Good.
but then I made a payment and $692.17 of that payment went toward reducing the balance. So what was my ending balance?
2107.83.
Okay.
Take a second and catch this, you guys. These 3 steps are represented really clearly over here in Pete's work, and we're going to do them over and over through the life of the loan. And what you'll notice is although we paid $713.17, our loan didn't quite go down by that amount,
Sure.
right?
And that makes sense.
Because we got to pay a fee for borrowing this money, all right? Okay, let's do month 2. I'm here now, Pete, all right? We
like
can
it.
keep your same calculations and just change some numbers, I think. First
think
of
so.
all, what is the starting balance?
Well, it'd be that 2107.83. It's going to match what
So
we have
this
up
number
here.
comes right over here, 2107.83. Obviously, the ending balance at the end of month 1 is the starting balance at the beginning of month 2. Now my payment.
Stays the same.
Beautiful. In fact, Pete, can I go ahead and fill all these out right
You
now?
can.
That's awesome. All 4 of the payments, and this is if this was the car loan, it would stay the same all the way through. In fact, that's the only column that's going to stay the same. These are going to change,
Yeah.
right? Now, question for the crowd, and Pete, you can think about it and give us the
Okay.
answer. Is this interest going to go up as I go down, or is it going to go down? Take a pause and answer that question. Is this interest going to increase or decrease as I go down through the loan? Okay, we're back, Pete. What's the answer and why?
Yeah, so if you think about it, this was the rental fee when you owed $2,800. Shouldn't the rental fee, if you owe less than that, be smaller?
Has to come down.
Has to come down.
Borrowing less chairs.
And in fact, the calculation is real similar to what we just did for interest 1, except for this number changed, right? Because my
Beautiful.
balance was different. So if I do 2107.83 right
So you
here.
can use your whiteboard and correct
Okay.
that, punch
so,
it in.
So
Or you can do it right up here if
You
you
want me
want.
to do it there?
I think so.
Yeah. So I could say I2.
The beauty of a whiteboard, right?
Yeah.
So you borrowed 2107.83, and hopefully you try these calculations at home and see how they work. The rest of it stays the same, right, Pete? The rest of the calculation.
Yeah.
I got an interest of $15.81.
$15.81.
Does that make sense to you, Pete?
Yeah.
Sure, it's going
It went
down,
down.
borrowing less. Okay, how about the next calculation?
And then my principal would be, let's see, the 713 is the same, but I don't want to minus the 21
Right.
because I pay less interest. In fact, I pay $15.81.
Beautiful. Look at the flow and the repeating nature of this loan. I got a value here of $697.36. Oh, Pete, I just observed something.
What'd you see?
While this is going down, this number is increasing as I go
That's
up, right? In
good
fact, by the
news.
same amount, isn't it?
Yeah, that's good news, isn't it?
That's right. The extra money that I saved in interest now went to principal.
That's why we want to do an amortized loan instead of a simple interest loan. Bring it.
Love it.
That's good.
Okay. Ending balance for this I got, Pete, is $1,410.47. Tell them how we got that.
Okay, so let's see. Where was I? Our
were in-
balance.
You were in your
was-
a balance of 2107.83 at the beginning of the month. You got 697. You're doing lots of erasing. I love it. 697.36, and it ended up with 1410.47.
Perfect.
Although the numbers changed, the rhythm did not, right? This minus this equals this. Notice the repeating nature. Okay, we won't bore you with the next 2 lines. Pete's done. He just tossed his marker.
Yeah. Well,
But
it's not.
We're going to fill these last 2 lines in for you and come back and revisit it with you. Okay, we filled in the rest of the amortization schedule. It's a very short loan. It's a 4-month loan. And here it is. And as Pete predicted, we might get a little bit of an unclean answer at the end. Normally, your amortization schedule will go exactly to 0 every time. Why is there 2 cents left over, Pete?
Yeah, we rounded off our monthly payment.
Yeah, we had a half penny. We kind of cheated ourselves out of it. And
Yeah.
4 half pennies makes 2 cents.
Yeah, so your last payment might be 2 cents higher.
Yeah,
so that
that's
you get
okay.
into 0.
So you can just go to the bank and give them 2 more pennies at the end of the time, maybe.
Yeah.
2 things I want you to really hone in on as you look at this schedule as we wrap up this session. Number 1, what do you think the total of these 4 numbers is? This is the principal column. What do you think is the total of those numbers? Take a second and try to answer that. Okay, Pete, what do you want them to see when they total these numbers up?
If these are the numbers that I needed to pay off my loan, then those numbers, which were applied toward reducing the loan balance, ought to add up to the amount of the loan.
Exactly. That is the total you paid. All right. Question number 2. How can I find the total interest in this loan? Well, we won't give you too long of a pause here, but just take a short pause and try to answer, how can you find the total interest in this loan? Okay, we're back, and I hope that you answered this one because Pete showed you last time. Pete, how would you answer them to find the total interest in a loan?
Well, actually, I'm looking at this, and I wouldn't answer it the same way probably because the numbers are in front of me, right?
Got it.
Yeah, so these are the amounts of interest that I paid each month. Might as well just add them up.
Now, probably you did that because it was a 4-month loan. What if
Yeah.
it was a 36-month loan?
Yeah, if it was a 36 or if it was a lot more rows, I would just take the monthly payment times the number of payments per year times the total number of years. Just how much money I gave back.
Exactly what you did in our previous example.
And then I'd have to subtract off the amount that they gave me up front.
Right.
That's the difference.
But that should equal the total of all these numbers, right?
Absolutely.
Beautiful.
Check your work.
Okay, one final question to send you off with. How can I save money on this loan? If a person had to take this loan out, they got to get the diamond earring, it's going to go. So I really can't change this number. How could I save money? Chew on that, and we'll pick it up next class.